Greetings, everyone. Today we're going to explore isolating variables. Now, we have done this in the past. I do have other videos, but this video is a little more geared towards preparing for solving systems by substitution. Part of that process is going to be isolating X or isolating Y. So very specific examples today. We do have a foldable, or you can jot them down in your notes, and just make sure you're watching the correct video. If you need to, see my YouTube playlist to see if you're in the right spot. All right, let's take a look at example 1. Our goal on this one is to solve for y, meaning I need to isolate y. So that means the y doesn't move. Well, let's see what we can move. Instead of a subtract 4x, if I'm kicking it to the other side of the line, we're going to add 4x because I'm undoing it. Now I can't actually add these because they are unlike terms, so I write it as I read it. Now I chose this example because students often stop here, but we're not done. Technically, there's a -1. Instead of times -1, let's divide every piece by -1. That gets me a -4 and a -4x. And so what we're going to do as we continue in substitution, we're going to use this expression and we're going to substitute it in. All right, let's take a look at example 2, and you'll notice it's the same equation, but this time we are solving for x. So that means the x cannot move. So first thing I'm going to do is I'm going to add y to the other side. The -4x falls down, equals, and I write it as I read it, 4 plus y, since they're unlike terms. My goal is still to get x by itself. Instead of -4 times x, let's divide every piece by -4. The x falls down, equals falls down. 4 divided by -4 is -1. 1 divided by -4, it's going to be negative, but it's going to be a fraction. That's okay, 1 over 4. If the smaller number's on top, it's a fraction. So we're going to keep it as -1 minus 1/4 y. That's okay. Let's take a look at example 3. In this new equation, my first goal is I am going to solve for y. So the y has to stay. So the first thing I'm going to do is I'm going to kick that 6x over. Instead of positive 6x, let's minus 6x. I write it as I read it, and the -3y falls down. Next, I have a -3 times y, so to undo it, I'm going to divide every piece by -3. Careful with that negative, okay? Opposites go away. The y falls down. -12 divided by -3 is positive 4. -6 divided by -3 is positive 2. Okay, so we have isolated y. Our signs have changed all kinds of ways. But now I have my expression that is ready for the substitution method. All right, example 4. Notice it's exactly the same, but this time we're going to solve for x. So instead of -3y, let's add 3y. I'm going to have a -12 plus 3y. I write it as I read it. Since they're unlike terms, we can't add or subtract them. Next, instead of 6 times x, let's divide every piece by 6. The x falls down. -12 divided by 6 is -2. A 3 divided by 6, the smaller number's on top, so we actually have to reduce 3 over 6. I can cut both of those by the same value, not by 2. 3 doesn't divide by 2. I got to cut each of them by 3. That gets me to a 1/2. 1/2 y. That is my expression that I can use for substitution. Example 5, we're going to solve for y first. So I'm going to draw my line. Instead of +1, we're going to -1. Now where should I write it? Right on that left side, we write it under the 7. We can actually subtract. We have like terms. So the 3x falls down. 7 minus 1 is 6. The 4y falls down. All right, we actually had a like term. Next, instead of times 4, let's divide by 4. The y falls down. 3 doesn't divide by 4, so we're going to keep it as 3/4. 6 doesn't divide by 4, but it does reduce. Remember how I showed you this? We're going to just cut each of them in half. That would give me a 3 and a 2. So we have 3/2 as our number. This is okay. You're going to get fractions. It's going to happen. It doesn't matter. What it did is it created an expression that we can plug in. And as predicted on example 6, the same equation, but we're going to solve for x this time. So I'm going to draw a line down my equal sign. The x stays. So instead of plus 7, we want to minus 7. Now, where should I write it on the other side? Yeah, under the 1, we actually have like terms. So it's positive 1 subtract 7 is negative 6. Next, instead of times 3, let's divide every piece by 3. We want to undo it. 4 does not divide by 3. 4 does not simplify over 3. But 6 does divide by 3. That gets me a nice clean 2. So in this case, we now have our expression that we can use. Now again, this is the beginning of completely solving by substitution. So this does take some work. You got to be confident in this before we can move on. So let me know if you have any questions. Check out Google Classroom. I do have other isolating videos if you feel like you need more practice. And until next time, have a good one.